A quick lesson on drawing Lewis structures for ionic compounds. So when you're asked to draw a Lewis structure, one of the first things you want to do is figure out whether it is molecular in nature or ionic. What you're going to do is look at the electronegativity difference. So hopefully you still have that chart that has the electronegativity differences. If not, you could probably find one through a Google search. But generally speaking, if the electronegativity value is 1.6 or higher between the two elements that are in there. For example, if you had sodium and chlorine, the difference in the electronegativities is greater than 1.6. That would be ionic in nature. If it's less than 1.6, go ahead and treat it like a molecular structure. So for ionic structures like sodium chloride, what you would do is you would look at it and you would think about, okay, in this, the formula for sodium chloride is NaCl. There's one sodium and one chlorine. You would look at the charge of the sodium. The sodium on the periodic table is a +1 charge. The chlorine is a -1 charge. You're then going to draw the Lewis structures. So sodium normally has one valence electron, but if it's going to be +1, that gives away that one valence electron. So we aren't going to draw any valence electrons around the sodium. I'm going to put it in brackets. I'm going to put a little +1 there. Then next to it, I'm going to put the chlorine, which normally has 7 valence electrons, but if it's -1, that means that it gained that electron from the sodium. So I'm going to complete the Lewis structure for chlorine with 8 electrons around it, put it in brackets with a -1, and then do a little dotted line, and that represents your ionic bond. And that's the Lewis structure for sodium chloride. So you could have things like calcium bromide. So you'd have CaBr2 is the formula. In this case, calcium has 2 valence electrons. It would lose both of them, so it's going to become Ca+2. And then there are 2 bromines that each have 7, but you're going to draw them with 8, where each bromine will gain 1. So I'm going to put a bromine over here, and I'm going to put a bromine over here. Put those in brackets. Do your 8 electrons around this one, your 8 electrons around this one. Minus, I would probably sneak that inside there if I could, but I'm just trying to do this with one hand. And then connect it with your ionic bonds, and there's your calcium bromide. If you had a really complex one like Al2, O3, something like this, what I would probably do is something like put your oxygens next to each other like this. They're going to end up with all of the electrons around them in their brackets. So you're going to have that. There's the 8 around that, the 8 around this, and the 8 around this. And then maybe put an aluminum up there and aluminum down there. Those are each going to be +3 because they're in the +3 column. They each lose 3 electrons. And then do your dotted lines kind of like that. And that's how you do ionic Lewis structures. For the covalent Lewis structures, I think you probably already have notes, or you may be able to figure it out from the other video that I've shared with you. If not, send me an email and I will try to create another video for that.